Could we ever wake up and find that an entire ocean has disappeared? Welcome to This Explainer. Today, we're diving straight into an epic, honestly almost cinematic mystery about our planet's shifting oceans. You know, when you look at a globe, all those vast expanses of blue just seem so permanent, right? Fixed, indestructible. But Earth is actually this incredibly dynamic system. And the reality of our oceans is way more complex and honestly way more fascinating than what a simple map might suggest. So, let's ask that question again. Could we ever wake up and find that an entire ocean has disappeared? I mean, it sounds like the premise of a blockbuster sci-fi movie, doesn't it? But to really understand the true nature of our dynamic Earth, we actually have to take this seemingly impossible scenario seriously. We need to explore the actual science behind how water and land interact over deep time. Okay, let's dive into this. While oceans cover roughly 70% of the Earth's surface, what's truly staggering is the sheer volume of water we're talking about. The oceans hold a massive 97% of all the surface water on our planet. 97%. With that much water, you might be wondering how on Earth it could ever possibly disappear. Well, to answer that, we first have to figure out where it goes on a daily basis.
Because the ocean's contents, they aren't static at all. They're actually in constant motion through the global water cycle. It's like a giant, endless engine. Step 1. Solar energy causes massive amounts of evaporation right off the surface of the sea. Step 2. All that water vapor rises up into the atmosphere and condenses into clouds. Step 3. Those clouds are carried over land where they release the moisture as rainfall or snow. And finally, step 4, that water eventually makes its way back to the ocean via rivers and groundwater flow. It's just a continuous, dynamic loop.
So, the absolutely fundamental takeaway here is that the water doesn't just vanish into the void of space. It is endlessly recycled. The ocean and the atmosphere are kind of locked in this perpetual embrace, constantly exchanging vast amounts of energy, water vapor, and chemicals. And as long as this physical and chemical coupling operates like it does today, the total volume of water on our planet stays relatively constant. It just changes locations and states.
Part 1. Locked in ancient ice, the climate shift.
Now, what's really interesting about this slide is what happens when we stretch our perspective beyond our daily weather and start looking at thousands of years of deep time. We see some incredibly dramatic changes. During the last Great Ice Age, huge amounts of ocean water were literally transformed into massive continental glaciers. Because all that precipitation fell as snow and just stayed frozen on land instead of flowing back to the sea, it caused a staggering 100-meter drop in global sea levels. We're talking over 300 feet of water, essentially just drained right out of the ocean basins. Tracing this timeline really puts things into perspective. It shows us exactly how changing climates can temporarily lock water away. Around 36,000 years ago, the last Great Ice Age began, and those massive glaciers started to form. Fast forward to 18,000 years ago, and glaciation actually reached its peak. The sea level was so incredibly low that the outer continental shelves of the world were fully exposed as completely dry land. Then, by about 10,000 years ago, the Earth warmed up, those massive glaciers melted, and the sea levels rapidly rose again, flooding coastal valleys all over the world. And this whole process brings us to a concept known as submergence. Submergence is simply the flooding of land due to rising relative sea levels, often caused by those melting continental glaciers. As the Ice Age glaciers melted, the oceans swelled. A really perfect example of this is actually the Chesapeake Bay on the U.S. East Coast. 18,000 years ago, that was just the ancestral valley of the Susquehanna River. But as sea levels rose, submergence completely drowns that ancient river valley, reshaping the coastline into the massive estuary that we know today.
Part 2. Shifting plates, shrinking oceans, the tectonic shift.
Let's move to and see how this builds. If ice ages can drain the oceans by 100 meters, zooming out millions of years introduces a totally different mechanism, one where the physical ocean basins themselves actually begin to move. It is absolutely crucial to understand here that while the water on Earth remains, the basins holding that water are not permanent. You kind of have to think of the ocean basins as giant rocky containers. The water inside, it's just along for the ride. Over millions of years, these containers are constantly being created, reshaped, and sometimes entirely destroyed by the geological forces of our planet. You know, for a really long time, people just assumed the ocean floor was flat and static, nothing to see there. But mid-20th century discoveries completely flipped that idea on its head. Using sonar, scientists found this massive, rugged global mid-ocean ridge system that winds around the entire globe, kind of like the seam of a baseball. They also discovered symmetrical magnetic striping on the rocks, which proved that the absolute youngest rocks are always found right at the crests of these ridges. And finally, they realized that global earthquakes were heavily concentrated at deep oceanic trenches. So, what does this all mean? Well, all of this geological evidence pointed to one really brilliant mechanism: seafloor spreading. Basically, deep within the Earth, new magma rises up at these mid-ocean ridges. It cools down and creates brand new oceanic crust. This new crust then pushes outward, actively recycling the ocean floor like a giant, slow-moving geological conveyor belt.
And this brilliantly illustrates a really profound reality about our planet. Because the Earth itself isn't actually getting any bigger. If new crust is being created in one place, old crust has to be destroyed somewhere else, right? So right now, the Atlantic Ocean is experiencing vigorous seafloor spreading, which means the Atlantic Basin is actually expanding. But to compensate for that, the older crust of the Pacific Ocean is slowly being pushed into deep trenches and consumed right back into the Earth's mantle. So literally, the Pacific Basin is actively shrinking.
Part 3. The scale of deep time. Human versus geological timescales.
So, the crucial point is this. Can an ocean actually disappear? Yes, physically, a basin can be totally consumed by tectonic forces. But to truly grasp this, we have to contrast our very brief human experience with the epic life cycles of the Earth itself. The timescale of deep time is, honestly, almost unimaginable to us. When we look at the atmosphere and our daily weather, we're seeing changes happening in minutes to days. Ocean circulation patterns, they shift over months to decades. Glacial ice ages, like the one that dropped sea levels by 100 meters, those operate on a scale of thousands of years. But plate tectonics, the force that actually creates and destroys entire ocean basins, that operates on a scale of millions of years. Which brings us to our final thought for this explainer. The water that makes up our oceans isn't leaving the planet anytime soon. But the maps we draw today, they're really just a temporary snapshot in Earth's long, incredible history. An ocean may disappear from a map someday, but Earth's oceans change on a timescale far beyond a human lifetime.